Welcome to Hartman Math. This is lesson 3.9, solving quadratic equations by completing the square. So this is now our third method for solving quadratic equations. We learned how to do it by factoring, get it equal to 0, factor, split it apart. We learned how to do it by square roots, by isolating the part that's squared, square rooting both sides, remembering the plus or minus. But that only works some of the time. So now the last two methods that we're going to learn, this one and one later, will work in all situations. Now, for this one, we're only looking for it for a specific type. Now, we've learned how to do the skill work for completing the square in a previous lesson. Example number 1. Here's what makes this good for completing the square. It starts with just plain x squared. And the b part is even. That's critical, because if those are the cases, completing the square should be pretty easy to do. Now, I might try factoring this first, but I don't think it's going to work for the plus 6. We could come up with x plus 1 and x plus 6, but that would give us a 7x in the middle. Or we could try x plus 2 and x plus 3, but that would give us a 5x in the middle. I don't think we can get a 6x in the middle by factoring. But I might think of that first if the problem just essentially said to solve. So now that that's done, how do we solve by completing the square? Step number 1. We want to get the x squared plus bx by itself, so we want to get rid of the plus 6. We're going to go minus 6 on both sides. Notice I'm leaving a gap here because I'm going to fill that in with the work that we did yesterday. Remember, in the previous lesson, 3.8, we said to find the c value that completes the square, that's that first part of the lesson, was we were going to take the positive 6, we were going to divide it by 2, get positive 3. And then we were going to square that. We got positive 9. So that's step 2, is add that c that we were working on in the previous lesson. We're going to add it to both sides. So once again, we divide this by 2, we get positive 3. Squaring that, we get positive 9. We're going to add 9 to both sides. Now the second part of the 3.8 lesson was to take this expression and write it as a binomial squared. So it was always x, and then what did we square to get the plus 9? It was the half of this. It was the plus 3. So it was x plus 3 squared is going to equal, and then we'll just go ahead and evaluate right there. So that's step 3. Write the left side as the square of a binomial. Once you get to here, we're now going to solve it by using the square root method that was learned previously. We're going to square root both sides. When I square root the left, it just undoes the exponent, as those are inverse functions. If I square root the right, remember I'm going to get two answers. I get positive and negative. So square root method, plus or minus root 3. To finish this up, we want to get x by itself. We want to undo the addition here. We're going to subtract. I like to do it in front of the plus minus. So we're going to get x equals negative 3 plus or minus the square root of 3. Pause here as you work through, try to solve this by completing the square. You can play when you're ready. So same thing. It's going to work out pretty well because it starts with just plain x squared, and this is even. Step number 1 was to get rid of this constant. So we're going to add 15 to both sides. We're going to leave a gap. Now let's figure out what number completes the square. Our c value, add it to both sides. So we're going to take the negative 10, divide that by 2. You get negative 5. Square that, you get 25. C will always be positive. You will always be adding. Now on the left side, we're going to write that as the square of a binomial, x. And then what did we square to get plus 25? We squared half of this. It was negative 5. So x minus 5 squared equals. Let's now square root both sides. Don't forget the plus or minus. Now with the square root of 40, I think we're going to need to simplify it. We're going to need to break that up. Think of a perfect square that goes into 40. thinking 4. So root 4 times root 10. We can add 5 to both sides. I want to do that in front of here, so I don't think that I'm actually adding it to the 40, because it's not really 40, it's a square root of 40. All right, so we broke up the root 40, we added the 5 in front. What's the square root of 4? It is 2. That's as far as we can go. Now, if that root 10 wasn't there, I'd go farther. I'd go 5 plus 2 is 7. 5 minus 2 is 3. Those are my two answers. But with the root 10, these are now not like terms. This is 2 root 10. This is certainly not 5 root 10. So we can't add them together. We're done right there. Example number 2. I'm not really liking that 2 in front. That makes the completing the square a lot harder. But if we notice, everything's divisible by 2. I could just divide both sides by the 2 and turn this into x squared, and then it might be easier to do the completing the square. So let's divide everything by whatever that leading coefficient is. We're going to divide everything by 2. So now we're ready to complete the square. Notice that there's no constant over here, so we're kind of ready to do it anyways. Before we do that, let's see if we can factor it. So if we've got it equal to 0, we can maybe try factoring it. How do we get the minus 4? We go x minus 4, x plus 1. That would give us a minus 3x, I know. X minus 2, x plus 2. Now the x's would cancel out. We'd have 0 x's. So it's not factorable. So let's now keep this on this side. We'll move the 4 back, but leave some space. Now we're ready to complete the square. So what number is going to complete the square that we're going to add to both sides? Let's divide this by 2. Get positive 1. Square that. You get positive 1. Let's add 1 to both sides. The left side becomes x. What did we square to get this? Well, it was when we divided this by 2. It was positive 1. Let's square root both sides. 5 is a prime number, so we can't break that down. Let's undo the addition. I want to put that on the right side in front of the plus minus sign. There we go. X equals negative 1 plus or minus the square root of 5. And that one's done. All right, go ahead and try this. Same thing. Watch out for that 3. We're going to have to deal with that. Pause here until you're ready. All right, let's divide both sides by 3. Let's get rid of that 3. Now, is that factorable? X and x. There's really only one way to make the plus 5, especially without being minus. It'd have to be x minus 1, x minus 5. That would make a minus 6x. So it didn't work there, not factorable. So we're going to go to complete the square. So we're going to need to get rid of the plus 5. Now we're ready to complete the square. Let's find the c. Divide this by 2. Get negative 6. Square that, you get 36. Add that to both sides. On the left side, we're going to write it as a square. X, what did we square to get the 36? It was negative 6. Let's square root both sides. 31's a prime number, so we can't split that one up. We're one step away. Let's undo the subtraction. Let's add 6 to both sides, put it in the front. There it is. That's it for today. See you next time.